Okay guys, as promised, here is a video going over this worksheet. So, on this worksheet, you're going to take whatever equation you have and to graph it, instead of putting it in slope-intercept form and starting with this y-intercept and going off of the slope like we were in the other worksheet, this one we're just plotting points and we're finding individual points by just plugging in different x numbers and solving it each time. Okay, so let's see what happens. I'm going to copy this equation down here. What happens if x is, let's try 0. If x is 0, then we got negative 0 plus y equals 1. Okay, negative 0, that's just 0 plus y equals 1, so y equals 1. So, if x is 0, y equals 1. So come up to the graph, x is 0, then y is 1, right there. Okay, let's find another point. What if x is, so start off with our equation, negative x plus y equals 1. What if x is 1? Then we've got negative 1 plus y equals 1. Now we got to solve that and find y. So I'm going to add 1 to both sides. Negative 1 plus 1 is 0. Plus y equals 1 plus 1 is 2. Y equals 2. Okay, so up here, if x is 0, y is 1. This one we found if x is 1, then y is 2. So come up here, if x is 1, then y is 2. And let's do one more point to make sure that we've got the line. It looks like the line's going this way. We got to do at least one more point just to be sure. Okay, so again, we're going to start with negative x plus y equals 1. And this time, how about we say x equals 2. Okay, let's put in a 2 where the x is. So then we've got negative 2 plus y equals 1. We got to solve that to get y, so we'll add 2 to both sides. Negative 2 plus 2 is 0. Y plus nothing is y. And 1 plus 2 is 3. So y equals 3. When x is 2, this equation gives us y equals 3. So we're going to go to x is 2 and find y is 3. So x is 2, y is 3. And you can see how the line's going from those 3 points. 2 points will be enough, but I want you to do 3 as a backup in case, just to make sure that the other 2 points are looking good. Okay, so you're taking this equation, putting in different numbers for x and seeing what you get for y. And then those x and y coordinates are giving you points that you're going to plot on the graph. And from those points, you see where the line's going and draw the rest of the line. So let's do the same thing on number 2. Number 2, this is the equation. X minus 6 equals negative 2y. X minus 6 equals negative 2y. So let's put in a 0 for x and see what we get. So if we put in 0 for x, we'll get 0 minus 6 equals negative 2y. 0 minus 6 would be negative 6 equals 2y. And to get rid of multiplying y by negative 2, I am going to do the inverse, or divide by negative 2. And if I divide that by negative 2, I've got to divide this by negative 2. Negative 6 divided by negative 2 would be positive 3. Negative 2y divided by negative 2 is 1y. So y equals 3. So if x is 0, we get y equals 3. So up here, we go to x is 0, y is 3. Put a dot there. Okay. Now we're going to take that same equation and put in what if x equals 1. What if x equals 1? So I come down here. I'm going to start over. X minus 6 equals negative 2y. And this time we're trying what happens if x is 1. What if x is 1? Then we'll get 1 minus 6 equals negative 2y. Okay, and if 1 minus 6 is negative 2y, that means negative 5 equals negative 2y. Okay, now what are we going to have to do to get y? Same thing as we did on the last one, divide both sides by negative 2. And this one, you might notice, is not going to be an even integer. 5 divided by 2 would be 2.5. You could call it 5 halves if you want, or 2.5. So if x is 1, y is 2.5. If x is 1, y is 2.5. If x is 1, y is 2.5. So this one's a little weird because it's not on an integer. So let's do at least one more point to make sure that we have the way it's going correct. So I'm going to start with the equation again. X minus 6 equals negative 2y. And let's see what happens if x is 2. If x is 2, we have 2 minus 6 equals negative 2y. 2 minus 6 is negative 4. And so I have negative 4 equals negative 2y. Again, we can divide both sides by negative 2. And that will give us just 1y, or y on this side. Negative 4 divided by negative 2 will be positive 2. So if x is 2, y is 2. So I'm going to come over here. If x is 2, y is 2. And those all do line up, and we can see it's going down 1 over 2, and you could plug in some more points in here, some more x's, and get more points if you want that way, but I'm just gonna see how those 3 line points are going. Keep going with that same pattern, and it's gonna look like that. So there's number 2. There's number 2. I found what if x is 0, then y is 3. What if x is 1, then y is 2.5. If x is 2, y is 2. And from those 3 points, you can see that the line's going like this, and fill in the rest. Okay. These two, you're going to do the exact same thing. Say, what if x is 0? What if x is 1? What if x is 2? And find the y that goes with each x, plot those points, and get the graph and see what it looks like. So just to let you know, well, I'll come back and talk about these two in a second. But let's look at this page, because this page was supposed to kind of be a lead-in to our next assignment, the 2.3b. The 2.3b, you use the slope-intercept form, the y equals mx plus b. And you know, if it is an equation written like that, like if it's y equals 3x plus 4, then you knew that 4 is the y-intercept and 3 is the slope. So you'd go to 4 on the y-axis, and you'd start going up 3 over 1, up 3 over 1. So this is just like that. So initial value, that tells you the y-intercept. And rate of change, that is the slope of the line. So on these guys, all you've got to do is put in the initial value on what that's just going to tell you where it hits the y-axis, and then you're going to go according to the rate of change from there. Rate of change is 3, or the slope is 3. That means it's going to go up 3 over 1, up 3 over 1, up 3 over 1. And that's what it's going to look like. Okay, this one, the initial value is 3, so it's going to cross the y-axis right there, and then the rate of change is a half. That means it's going to go up 1 over 2, up 1 over 2. You can see it's a little easier doing it this way than calculating each individual point separately. If you know these two numbers, you can just get what the graph looks like right away. So initial value -2. That's right there. Rate of change -1/5. So what I'm going to do is go down 1 over 5. And So down 1 over 5, down 1 over 5. Whoops, that should be right there, not right there. And it's going to look like that. Okay. So use that, get that point, then use this. You go like that, and get that point, and that point. Last one, rate of change is 4, initial value 1. So you might want to try to do this on your own real quick before you watch the rest of this, but I'm going to go and do it. So initial value 1, right there. Rate of change 4. So where am I going to put the next dot? I'm going to go up 4 over 1. And go backwards a little bit. So it's going up 4 over 1, up 4 over 1, up 4 over 1 for rate of change of 4. And use my ruler, drawing the rest of that line nice and straight. And there we go. So, the point of this assignment, which you guys had a little more trouble with it than I thought you would, but the point of this assignment was, you see, oh, if I have an equation written some random way, I can go and take different x's and calculate the whole thing every time and find what y would be, and start over and try a different x and find what y would be, and start over and put in a different x and find what y would be, and get these points and then get the line drawn. And you can always do that, but it's really a lot easier if you just have these two numbers. You can draw it right away. And that's what we were doing on the next assignment. If it's written like this, it's nice and easy. We can just draw it right away without doing a whole bunch of calculations. On these problems, we're doing it the long way. On the next assignment, we were starting to do it the shortcut way by just changing this equation to look like this, and then we can just do it like these problems and just draw it by plotting the y-intercept and then going according to the rate of change or slope. So I'm going to do this number 4 really quick that way that we were doing on the next assignment, so you can see what I'm talking about. So we could do what we did on number 1 and number 2 a minute ago and just try putting in, leaving this equation how it is, putting in different numbers for x and seeing what y we get for each x and putting those individual points. But the easier way is if we just put the equation into standard, into slope-intercept form before we start messing around with points. So if you notice, you could divide both sides of the equation by 4, and the equation will become y equals negative 3/4 x minus 8 divided by 4 is 2. So once we have it this way, instead of putting in the x's like we were doing on number 1 and number 2, we can just say negative 2 is the intercept. If x is 0, that part is 0, so we get y equals negative 2. And then we can just go according to this slope, negative 3/4, down 3 over 4. And we could go back 4, up 3 really carefully there. And it's going to look like this. Okay, so this is more the way that we're starting to do stuff on the next assignment, but you can do it this way on this assignment too if you'd like, just for these two. And this one, we want y equals mx plus b. So if we add 2 to both sides of that equation, that's going to become negative 3x plus 2 equals y minus 2 plus 2 will go away and just leave the y. And so we got y equals negative 3x plus 2. So the y-intercept will be 2 and the slope will be negative 3. So we'll go down 3 over 1. And that's what this line will look like. Okay, so this assignment was to show you that instead of calculating y every single time from scratch, which works like we did it on these two, but instead of doing that, we can just change the equation carefully into the slope-intercept form and get the points really quickly and graph the line really quickly from that. And let me look at the last problem really quick. List of the dogs and the number of cats. If there's 2 dogs, there are 13 cats. 3 dogs is with 17 cats, so dogs, cats. If there's 3 dogs, there are 17 cats. 4 dogs will be 21 cats. 5 dogs will be 25 cats. So go 5 dogs, 25 cats. And you can see the pattern here. It's going up 4 over 1 every time. Up 4 every 1. So it's going to look like that. So number of cats is the y, number of dogs is the x. I didn't draw it down here because you can't really have a negative number of cats or dogs. That doesn't really make sense. What's the rate of change in the number of cats with respect to the number of dogs? It's going up 4 dogs for up 4 cats for every 1 dog. Up 4 cats for every dog. 4 cats per 1 dog. Or you could just say 4. 4 cats per dog. And what is the initial value? That's right here. If there's 0 dogs, there are 5 cats. Write an equation. Cats is determined by the number of dogs. So we're going to say C equals 5 plus 4D. Or you could say 4D plus 5. Okay. That's it. Hopefully that helps some of you who are getting stuck on this and confused when we were working on this in class last week. I'll see you guys on Thursday.